Hello everybody, we are live. Ah, yeah, that's great. Yeah, so sorry. Today I was a bit swamped with my work, so I haven't done the presentation. So today will be presentationless. Hi everybody. Hi Turtle. So if you haven't done that already, you can download our Lockdown Learning. You can just download the zip or copy the GitHub Git link. There is a new folder called Promises here. Although we are not just doing promises today, we are also covering callbacks, promises, and async await. They are just different way of writing asynchronous part of JavaScript. So if you try to open our promises folder, yeah, everything is in here, and here is some of my code called Magic 8 Ball, which is broken because half of the time it doesn't work. So we will use this Magic 8 Ball so I can show you how you can do callbacks, how you can do promises, and how you can do async await. So before starting with this, please go to the promises folder, open in terminal, right click it on it and open in terminal, and enter in your terminal down there npm install. So this will install all dependencies, including our parcel and including some other like plugins for, let me just put my mobile phone away, and some other stuff that is needed for this. It really doesn't matter. It's mostly just configuration stuff. It takes about, for me, it takes about 7 seconds. For you, it probably will take 30 seconds because I have already downloaded like a bunch of it. So yeah. And now in promises, you should have node modules, like everything installing here and so on. So the important files, like again, are index.html, our script file, and now the Magic 8 Ball. So the Magic 8 Ball is a code. We'll go through this code like on the end of this lecture, but we'll use it. So let's see, it just exports a function called ask that gets requires parameters question and callback. So yeah, let's try to write something with that. Okay, so the first thing that we need to, so we already done a little bit of asynchronous programming. Remember, like button click or image on load or something like that. We already done that, but that was on like user event. So user did something, and then we get an event, and then we get our function called. That's fine. That's total. We did it like a lot. We had like multiple different examples with that. But what we actually need is actually to understand how that, what way the function is called on our buttons. So there is a special like function that is called callback. So it's just the same as any other function there is, but it's actually has some parameters that are like required for it to be a callback. So let's just write it down. Actually, the first parameter is an error, and the second is the result. So this is not really a feature of JavaScript or anything like that. It's more of agreement of many developers. So we'll write all our callbacks or all function that we will call in some other in some other point like this. So let's write a quick. So let's write two functions. So the second function will be our callback that will actually write out our console log just error and result. And this function will actually do some stuff. Let's say do stuff. It doesn't really matter. So do stuff actually needs a callback to be passed. So another function should be passed to this function here. It maybe seems complicated, but we will see when on the end it's pretty easy to understand what's the problem. So what's the issue with this way of writing? So the do stuff function can call our callback function whenever it's needed. So let's say this function actually what it does, it creates a new string. So let's say text, or it has multiple statements in here. It doesn't really matter for our example. And what it does in the end, it actually calls callback, null, and text. So if we call the function do stuff with the callback function passed as an argument here, we will actually get back an asynchronous call of this function. Maybe it's better to demonstrate it first, so you will understand what's the deal. So you can see I'm calling do stuff here, and I'm passing callback function as an argument. It looks a bit silly, but you'll see that it's totally asynchronous. So let us try running this. I'll paste this in the okay. But let's try running this. Open with, actually, we need to open this in terminal and write npm run start. And we will get our localhost 1234. Oops, I clicked the wrong key. If you run npm start, you will get your localhost 1234 running. So let's try and paste this here and open the console, and you will see that our script.js tree, so our callback function, actually wrote out null some stuff done. So this is a way for sending some data. So let me double check if it's really asynchronous. So if we write something before this line, and we write something after this line, what do you think that will happen? So will it write out like before, then null some stuff done, and then after? Because up until now, everything that we wrote was totally synchronous except the button handlers. What will actually happen here, it will write out before, after, then it probably will write out the callback here, or some like mix of those. Maybe there will be like before, some stuff done, null, or an after, or because it's totally asynchronous, we cannot really know when the callback will be called. So let's try it like this. Let's see. Yeah, now it seems totally synchronous, but if we put like, I will just write a timeout quickly here. Just ignore this line for a moment. It's just, let's say 500 milliseconds timeout. You don't need to write this out. What will happen now, it will be totally asynchronous. So first you will say before, then after, then something else. It depends. Maybe if your computer is a bit slower, or if it doesn't have enough like processors, or no, it will probably write out before, then null some stuff done, then after. But this is like the old school way of doing asynchronous stuff. So let me try that with Magic 8 Ball. So let me try write this same stuff, but using the function. The function do stuff will be replaced by function ask from Magical 8 Ball. So let me try to do that. So let's include it in our file here. So import ask. Ask is the function from Magic 8-Ball. And then let's write it out. So ask, first thing that we need to do, say here is a question. Let's say, should I order pizza? And then a callback. So callback gets our error, not like this, but error parameter, and then some answer. So let's write out like this. So we have, yeah, that's this. And let's console log our error and answer. So I said it before that this Magic 8-Ball is totally broken. And 50% of the time, this will show us an error, and 50% of the time, it will show us an answer. So this is just the way if you do something in there and there is some like error or something like that, or an exception throws out, so it could be handled like in this part and not just so the problem is that error handling like in JavaScript is pretty complicated, because I don't wanna. So this is the problem here. I don't wanna get in like computer science really deep, as I said again. For now, I really want to get like the basics about asynchronous. And the problem here that if I talk about errors, I will go really deeply in event loops and so on. That is not really interesting. Let's say this is the best way of solving errors in asynchronous programming. At least until like 2012, this was the best way of handling errors in asynchronous programming. Let's say it like that. Okay. Okay, let us try to refresh multiple times. So first time we got error, Magic 8-Ball is broken. Next time we got null. So the first one is error, the second one is some result. So we got for question, should I order a pizza? I got very doubtful. I will paste this so it will be easy for you to follow me. Let me refresh again. I got not an error, but a replay hazy. Try again. Okay, I'll try again. I got null without a doubt. Okay, maybe I should order pizza. Let's try to get an error. Okay, error, magical 8-Ball is broken. So this is pretty cool. So we got maybe an error here, and we got all answer. If you don't get an answer error, we will get an answer, and vice versa. So what we need to do here for handling the callbacks, the best. To handle the callbacks, we should actually do an if here. So let's try it like this. If it's error, if it's not equal to null, then something, and if it's null, then so on. So one thing about errors, the error parameter here, it's agreed. So everybody agreed that callbacks should return null as an error if everything is okay. So that's just an agreement. It's not really a feature of language. So if error is null, then if error is not null, I wrote if not null, so I wrote it like this. If error is not null, we should actually log out the error. So let me just say this is a callback and our error message. So each error has a message property, so we can get like the description it and not just the random stack. And if we got some answer here, then we can write answer is an answer. So let us write. It's pretty similar to what we wrote before. It's just much. Okay, so let's try. Callback answer is yes. Okay, I should order pizza. Callback error, magical 8-ball is broken. Okay, fine. No, okay. No, magical 8-ball is broken. So it has about 50% of writing out something and getting an error. So what we do, if this is some like meaningful, if ask is some meaningful function, we would have some stuff here, some statements in here. If we have an error, like an error handling or something like that, or maybe calling this ask again, maybe something like that. And if it's not, if it's totally okay, then we can do something in here. So maybe I could put everything here in a function, like ask with callback, so it'd be easier for us to call it multiple times. And we can actually, we can call him ask callback here. And we can actually put something like before and after. So I will show you that it's totally asynchronous. Let's say before ask callback and after ask callback. Let's try to run this. Does this have less than? No. Okay, but I suggest put a function so we can call it multiple times, like this. And let's test it, like call this 4 times in a row. So you see what happens here. So the lines that are actually synchronous are actually our console logs, like ask callback and after callback, because you have before ask callback, after ask callback, before ask callback, after ask callback, and so on. We called the ask callback function 4 times in a row, and we get the callbacks, the results of it, or errors, we get afterwards. So actually it's about 1 second delayed, yeah, as you can see here. It's actually totally asynchronous. So whatever happens after this line, it will happen instantly. It should not wait for this statement to end. So everything inside of this block will be done totally asynchronously. And this way of writing this is actually called callbacks. So in a way, why is it asynchronous? So in our synchronous example, so we wrote some synchronous like function in functions, right? So Toril asked why is this asynchronous? And we actually returned the value back to our our code that's calling that function. In this example, we are not returning anything. We are actually calling another function that we passed here as an argument. That's why it's asynchronous, because it doesn't wait for this part to be completed. So functions that we can do maybe like this. Let's try to write 2 different like ask functions, one after another. So what this should do is actually we should get first this one, then this one. That's the logic. Like we should get console log, maybe error here and answer in here. That's the logic. Like when we were writing like our code, like one line after another. What will actually happen? And another function called ask. We will call this function here and this function here upon completion. Upon completion of that called function, so ask. So ask, when it finishes, actually calls this function here. So the functions that are written here go to a stack. Let's say it's a stack. Imagine, maybe better, like imagine a queue. Let's imagine they are waiting for to get to our clerk on the bank. So our function, whatever function comes first, like this one or this one, it gets served first. That's actually what happens. So let's not go too deep because I would need to explain how like more stuff works. But let's take it. So this is asynchronous because there is a function. So this function, this called function here, calls another function upon its completion. So that's why it's asynchronous. Because we are not getting a result from this function, we are actually console logging it. So we're console logging we're console logging like parameters of this function here, of this callback. It's not really easy to explain if I don't go deeper into computer science, and I'm trying like my best of like staying away from it because it's like a endless hole. So another problem, the JavaScript is actually totally asynchronous. Like there is a lot of like caveats in JavaScript and how JavaScript like function works. There is and it's a lot different than other programming languages. Of core engine of JavaScript is different than other programming languages, at least in runtime. So let's not really talk more about that. It's an interesting subject, and I'm really interested in computer science, but it's really hard to explain. It's really hard to explain. Let's imagine that every function goes to a queue, and it waits for the clerk to go and say, "What do you need?" If we say something like this, const result equals ask callback, this result will wait for this function, this called function to end. But if we don't write like that, it just goes in the queue and it does its stuff, right? So if you have a function in the function, when the called function finish, it actually calls a callback, and that callback goes to a queue. So if you have like multiple functions here, let's say multiple called functions here, it could actually happen that at some point a callback like moves in here inside of this imaginary queue. That's like the best I can do of explaining. I'm really sorry because this is quite complicated. If I want to show you like the next best thing. Like callbacks are really, really awful. And if you ever written like in any other language, if you've written a callback in another language, you'll know it just leaves you a bad taste in your mouth. And ask any programmer about callbacks, and it's like, oh man. But okay, let's say, okay, this is a callback way of writing. There is a better way of writing it, and then the better way of writing is actually called promises. So let me show you how to write a promise on this example that I have. It's the same thing. So should I order a burger? Let's say it like that. And what I need to do here, not write a callback here, but pipeline it like map and reduce with this dot then. Oh man. Okay. So then, and then afterwards catch. So it's similar. It's conceptually it's similar to callbacks, but this function that's passed in here. So t, let's say, or answer console log answer, and let's write here error. Console log error, and let's create this a bit more like this. So what this actually does is that the function that's passed here in the then part will be called only when there is an answer, and this will be called only if there is an error. So these are two like then and catch. So if we compare, let's just cut this out and compare these two parts. So these two parts are working in totally the same way. Let me just write this a little bit more beautiful. Let's prettify this. So these two are totally the same. At least they have totally the same results. They are not working internally totally the same, but they will pass us out the same results. Maybe I made a mistake here. This should be probably here, and this should be written here. So should I order a pizza? It returns, actually this is a callback way, so it returns error and answer parameters in our callback function. If error is not null, that means there is an error. If it's not, then there is answer. This way of writing, actually we say then means that it has some result, and catch, it means it has an error. So if we look at this, we will have, and let's write here promise. So we differentiate from those two calls. So what we have here is actually callback error, magical 8-ball is broken, promise error, magical 8 is broken. Let's try it again. It broke both times. Oh, now it's both answers, different answers. Error, and answer, and so on. So those two ways of writing are totally the same. So it's just it's a matter of opinion, which is better. I actually prefer promises, writing something like this, and not writing something like this. This is more wordy, and callbacks. There is a lot of examples that have callbacks, and that is just really unreadable and crazy. So this is much better way, and it started to be implemented in JavaScript and Node.js about 2013, 2014. So you imagine that this is pretty old, and it's used in production all around the world and so on. But this is not the best way of writing. There is another way of writing. So let's put this back in our function. And let me write here a function ask promise. And let's do the same thing for this ask part here. And let's say after ask promise. And let's say this before ask promise. So, and let's try to run ask callback and ask promise. So we have totally asynchronous here. So it's before, after, and then callback and promise error. So this way of writing this is actually promise handlers, because if you look at this, these are actually just methods of a promise object. And yeah, so some of the asynchronous require a callback, and some of them require the promise part. In our future, we will be using mostly promises, because these callback are pretty much out of the use at the moment. There are some okay uses of callbacks, but not really what we need to worry about. So this way of writing is much better and much easier. So then and catch, on then do something, and on error do something. This is pretty much similar to our on mouse enter or on click, is similar way of writing. But if you like miss this sketch, let's try to like remove this sketch part or just comment out the catch part. You will see that what actually will happen. Let's try. There will be uncut error here in Magic, and it actually will stop. It will stop our code from running because our console log is not like logged out. So it's pretty important to have then and catch for our promises. And you can imagine from like from the name of the promise, like promise in the real world work the same as in programming. So if you promise a burger or a pizza to somebody, you will wait a certain time to get that pizza back or that favor back. The same thing is when you do promises in JavaScript. You will wait for some times and then you will get back answer from it. And again, it's totally asynchronous because you don't know really, or you're not getting the pizza in our promise example. Somebody else is getting your pizza, and that should be, I should really like order a pizza. Or in this JavaScript, actually we are getting back some information from this called ask function. And I said, so this is, if we read here, this is like totally, this is asynchronous, and the problem, if we need to handle some stuff, if we have multiple statements, we need to write it in these like functions here. So if something happens, like if we get the result or answer in this example, we will need to write in this function like multiple lines of handling some data. In like callbacks, we'll need to write here multiple lines of data, or when we get an error, like error handling should be like written here or written like in this part here. And this is pretty bad because you have a function that need to like, if you want like pass some, let's say we want to get our result from here. So let result. So if we want to get like result, our answer value to this result value here, we will actually need to write something like this. And if you remember, I said that like passing an parameter to a global variable is just a bad way of writing code. And it's really bad in asynchronous because you don't know when this result will get the value that answer that's here. So if we want to use this result, so we can like set an answer here and try to console log. Let's try to console log this result. So we actually set the result, we set the value of the result to value of answer, and result is defined here. And we console log like result after as callback. What we'll actually get, we will get undefined. Why? Oh, we will get the result here because it's bundled. Why? Because the callback like happened like a second after we try to console log the result variable. So this is actually a very bad of writing something. If we actually want to get like some data from our promises or from our callbacks to be used somewhere else, we actually need to be really smart about it, and there is a lot of like conceptual thinking in that. So the problem like up until like 2016 was this was really awful. So we have a much better way, and it's actually called async await. So those are two different keywords, async and await, that we will use to describe our function, because we can define our functions to be asynchronous, and then inside the body of that function we can actually call await. Await actually waits for the function to be done, and so we can get result from that function. So let me write that. Try to keep keep with me. So this is let me just remove this. Try to keep it. So ask async. What we need to do is define this ask async function as async. So it writes like this. What this keyword async does is actually let us to write await inside the body of our function. And we will see how is that useful, because actually what we can do, we can write like this, write answer equals to ask, so but wait, ask, should I order sushi? You know what we got here? We can wait for async, ask async, and we can get this answer. We can return the answer out from here, or we can console log it in this our example, like here. This is async, but we still have a big problem, and that's error handling, and I will explain it in a second. We can call ask async. Let's try to call this. I will paste it. So this is famous. Okay, async answer, is it certain? It works totally fine. No, get me an error. Where is the error? Oh, okay. It's at uncaught. The same error we got when we removed the catch from promises, because actually async await uses promises in its background. It's not really easy to, it's really well hidden, let's say it like that. So 50% of the time it works perfect. Yeah. Okay. So actually what we need to do here is actually just handle our errors. So there is something called try catch, and try catch can be used in synchronous code as well as asynchronous code. It actually catches in a try block any error, and then it handles the errors in the catch block. So what we can do here actually is put try like this, put everything that is like questionable inside of the try block, and in catch block written like this, we can then like copy paste our console log for promises and write just async. So let me just write you out. So this part here will do the same job as promises and will do the same job as callbacks. The only like good thing about async await is actually that you can like control, so you can transform your asynchronous calls to synchronous one, because await actually says to our code, wait for the result of ask and put it in the answer. So this is like a great way of writing, and I advise everybody to write async await because it's really clear. You can read it like a synchronous code and it works totally fine. This just means transform our ask function that is asynchronous to asynchronous. So this actually just says, okay, transforms anything asynchronous to synchronous part. It actually works the same, but I can demonstrate that now it works synchronously. So I will say something, write something before and write something after. So all calls in the body of our asynchronous function will be done synchronously. So let's try that. Okay, let me try again. Before ask async, waits a second to get answer from our ask function, and then it writes after ask async. Okay, Do you see how this useful can be? So we can actually like ignore our callbacks, ignore our promises, and we can just use this for anything asynchronous. Let me get back. It's actually totally synchronous now. At least the body of our asynchronous function is synchronous. Async is just a keyword. It doesn't mean that our function should be asynchronous, but something in our body is asynchronous, and then we could use a wait to transform it in a synchronous function. I haven't like thought about these keywords. The keywords in JavaScript are all around awful. If you remember, like difference between var, let, and const, they're all variables, but they have some like different rules around them. So okay. So I showed you I showed you 3 ways of calling my magical 8-ball. So you can call it by callback. You can call it with promises, like use promises, because like ask returns promise, or it calls a callback if you pass a callback in there, or you can use it by async await. But why is that useful except for my magic ball? Actually, it's useful for getting data from a server. So I snuck something inside of if you look in your terminal, actually something says here. So if you read here, start is called, and I run start server and start client. Okay, so there is something like called JSON server here, and it runs on your port 3000. So let's try to go to this URL here. If you're running still your solution in terminal, actually there is something called localhost 3000, and there is a JSON server there. It's on your computer. Everything runs on your computer. So what do we have here? We actually have something like /food. You see a hyperlink here, and /Pokemon. If you click /food, we actually get pizza, hamburger, and hot dog. If you see here, this is similar to our JavaScript objects. It's actually just a JSON. JSON is JavaScript JavaScript object serializable notation. I'm right. JavaScript object notation is not it's JSON. JavaScript object notation. JavaScript object notation. Okay. I always forget like what JSON stands, but okay. So this is just if we take this everything that we have here, we got here, we can actually state something like this: const a equals to our object here, and tada, we got a new object. So this is totally okay way of writing our objects in JavaScript, but you can see there is some rules like double quotation around our property names, and that's just looks awful when you write in JavaScript. But that's totally fine. And we also have Pokemon. If you click on Pokemon, you can see this is our Pokemon data. All 809 Pokemon written here. So what we can do is actually get the data from this URL to our code. And we can get all this JSON here and put it inside of some our variable, like to our other site that's running on localhost 1234. The problem why am I saying now and not like before when we were working on Pokemon project is actually because you need to understand async await or promises, or at least callbacks for some bizarre reasons, to actually get the data from an URL, like a JSON data, to our code. So the way that we are getting anything in JavaScript is actually something called fetch. So what fetch does is actually you need to pass him a URL. So it's something like this. And when you press, it actually returns you promise. What we can do here is actually then write it just like promise or use async await or similar stuff like that. So this fetch returns a promise that actually has some value in it and some body that we can read. It says readable stream. Don't ask me what a stream is because it's really difficult to answer. I need a lot of computer science for it. So this promise here, what we can do is get this fetch, await it, and then we get all our Pokemons inside our code. Let's try to do that. So let us go back to our code here. We can delete this last call of async await, asking, not async await. And what we can do actually is write a new function here, and we can, or let's try it first with our let's first write it out with promises handlers. Let's do it like that. So what fetch does is actually takes our data from some server or some URL, and it gets it to our code or to our website or whatever we are running that code. So first, what we get here is a response from server. And what we need to write here is actually, we need to transform the response that we got from server to JSON, because when we go to this URL, we actually are getting JSON. Our fetch cannot really detect what type of response are we getting. Are we getting like some text or JSON or maybe some other things like HTML, images or something like that? We actually need to say, okay, parse it in this way, and you will actually return. Actually, what will you do? You will get the response, and then you will transform the response to JSON. Afterwards, we can call another times then to get the now data from response JSON, and we can write it like this, data, and we actually can console log the data here. What we need to do to avoid any errors, we actually need to write something that handles our error, something like this. Okay, let's try to run this in our fetch. What's the problem here? Localhost server, not server.pokemon. I wrote server for some reason. It's /Pokemon. Okay, look what we got. We got 809 different Pokemons. And if we go to our sources, or not sources, our network, we will actually see here that here's something called Pokemon. It's type fetch. It's actually fetched from script.js line 35. It took 17 milliseconds for it to get. So we can do it like this. So we can filter it out. And you can see that this Pokemon actually it has a response of our JSON. Remember in our promise here, we actually transformed the response to response JSON data to here. It works the same thing as map response. What you returned from the first then, you will get in a second then. Yeah, but what we can do actually is write this much better. What we can actually do here is rewrite the same thing that we've written here inside an async function. So we can actually say async function get, not food, Pokemon. We are getting Pokemon now. We can do something like this. Const response is equal to await fetch this URL. Then we can get data from awaiting response JSON. And then we can console log some data here. Let us try to actually call the get Pokemon function. So these two different ways, this is just two different ways of writing the same thing. There is some good way, because good things about this async, because we are actually awaiting, we are turning this function, these two functions to synchronous, and we are waiting their responses and not writing like a pipeline here. But what actually happens here, we will get two different like calls to the same URL. You can see here that we actually called HTTP localhost 3000 Pokemon and HTTP localhost 3000 Pokemon. We got the data from these two different URLs. I can go back. So what fetch does, it actually gets the whole data from some URL. It parses it in some way. So this is like to JSON, and then you can print it out. So gets or fetches the data, parses the data to JSON, then you can use the data as you like. Same thing, gets the data, parses the data, logs the data. If you want like error handling in our async function, you can write it. You can put everything in a try block, then write catch, and then you can console log error here. So the good thing of writing everything as async await, because it looks the same as we write our synchronous code, because this like promises or callbacks, if you try to read here, they stick out like a sore thumb, and they are not really nice to look at or read the code that's written like in promises like this or written in callbacks. And don't make me start if we want to like call a callback inside of callback and such like random stuff. Like this is, for me and for most of the developers now in JavaScript, this is like the most beautiful way of writing everything. And there's a lot of good things like turning your asynchronous code to synchronous with your await command. So what I wanted to show you is actually there are different ways of doing asynchronous stuff, but this one is that I prefer and that we'll use in the future. This way is actually, it works in every browser. So again, you can write, let me just write a quick asynchronous function here, asynchronous ABC, and then we can actually just console log ABC. So every browser can use asynchronous function, and if you say like there are promises behind our async await stuff. Yeah, so that's pretty cool. So this is the way that we can fetch some data from our URL, from our localhost 3000. And our localhost 3000 has some cool perks. We will use this JSON server on Saturday, and actually it has the query. You can use the query or the search parameters up here to filter your data. So if I wrote here ID equals 3 and I got a Venusaur, the same thing that I can do here is actually I can write, let me see, I don't know by heart if I know how to write this, but I will try. Yeah, or I can write something like this and filter it by name. So there are some cool stuff that we get out of the box that we programmed a lot to do it in our front end. So we will use this data that's on our JSON server to get the data for our Pokemon and not hard code our data inside the JavaScript. Yeah. So let's try just for some additional clarity, let's like put ID filtering in our get Pokemon function. So what we need to do is actually write the question mark ID if the ID is passed as a parameter. So what we can do here is actually pass ID here, and then if there is an ID, we can call a different away function, something like this, equals so it works the same as synchronous code, and you can use it. You can see here that I use the tertiary conditional operator. I remember how it's called. So if we pass get ID with number 3 in there, we should get our Venusaur. So let's just try that. Back here. Oh no, I wrote something. Where is my mistake? If ID, then do this. If it's not, then do this. What's the problem? I made a mistake somewhere. Can somebody spot that before I do? If I do if ID, then this, else. What's the problem? It says undefined and 3. So if it's 3, then you should return this part. Is it some problem with my multi-line stuff? I wouldn't be surprised if the error is just no. What have I done? Oh, I totally did. I forgot to write ID here. Oh man. We need to, yeah, so I wrote the query totally wrong. So the search parameters should look like this. So now it will work properly. Yeah, I will get just the Venusaur. And as you can see here, our get Pokemon here and get Pokemon tree, we got our we got our Pokemon before then we got all our other Pokemon data. Because again, we can transform inside of this body everything to synchronous, but this function becomes asynchronous. Oh man, a lot of stuff in here. So this async, actually the function becomes asynchronous, but you can use the synchronous, but you can transform asynchronous functions to synchronous inside of it. It's really fun. Yeah. But why is that? Why is that great? So asynchronous fetching is much better than hard coding all our Pokemon inside our JavaScript, because firstly, the larger is JavaScript, the slower our browser is the JavaScript. So that's the first part. The second part is we can just get our data by request and not get all 809 Pokemon in one bunch. So if there is some problem that we have, like let's imagine few billion of Pokemon, we actually can call them, get them all in one call. We will need to break that call in multiple ones, let's say by like 1,000 by 1,000 or at least 1,000,000 by 1,000,000. But what we can do with this fetching, we can actually just filter some Pokemon that are interesting to us, and then we can pass it to pass it as the data to our front end. So fetching data from somewhere is actually really, really important for front-end programming, because like your work consists about fetching the data, filtering the data, showing the data to user, and then updating the data. Like user can update the data. So those four things is like, I don't joke when I say this, 98% of like front-end development is just, okay, I need to get some data, I need to show that data or parse the data and visualize to my client, and then let my client update the data in some meaningful way. So there is a concept in programming that's called CRUD. I can use Wikipedia for it. So CRUD is actually a concept in, you can see here, persistent storage. What says create, read, update, and delete. So most of what we're doing in front end is actually creating, reading, updating, and deleting some data. This reading part in front end is actually visualization, because creating a user interface, a great way of showing your user the data and so on. But what you will do, you will actually call this for you will actually call 4 different functions on a collection of data. So let's say a Pokemon, you can create a Pokemon, you can read the Pokemon or Pokemons, you can update them and delete them. So what will we do on Saturday? We will actually create a CRUD operation upon our Pokemon collection here. So we have a Pokemon collection of 809 different Pokemon. What we'll do, we will add more Pokemon, we will update them, we will read them in some different way, then we can also delete them. So this is really, really important. The way that we are doing it at the moment, the reading data, is actually through fetching data from some URL. So let's say the technology that let us to read data or fetch data from some other URL is actually called REST API or RESTful APIs. You can see it here. So I won't go in depth about it. It's just important when somebody says REST or REST APIs or CRUD operation upon REST APIs, you will know that that's what we will do on Saturday. I will prepare a little bit more like a little bit more in-depth presentation about this, and show you just like basic concepts like behind like REST and behind like server-client communication. But what you know, when somebody asks you to fetch some data from some URL, you're actually using REST APIs. That's the just so you know, like you can think about that concept. So we had CRUD and REST API. The problem here is I really like talking about computer science, and I really like talking about patterns and so on, and I just wanted to keep it really basic and not go really in depth to computer science, because the problem here is these concepts are really hard to explain to be fully grasped. But let's say like CRUD is just the way that you can manage your collections of data, and REST API is a way of managing that data through HTTP, or fetching the data to HTTP, updating the data, and so on and so on. Yeah, so yeah, that's I I don't want to talk like an hour about why REST API is useful and what other ways of getting our data from server we can there are and so on, because I presume, at least I know, because there are three viewers and I know who you are, so I know that you are pretty new to programming. So I don't want to bother you with some computer science or like in-depth talks and lectures, because that's not really important. It's much more important to you to know how to write code on some how to write a code for some app that you want to do, or some website that you want to make, and not to understand what happens when I call create on REST API and so on. You just want to know like what are like the consequences of that. So please ask me any questions. I know this is kind of confusing. I just wanted to show you the end product of it, and the end product is something like this. This is fetch is the pretty much the only asynchronous function that we'll be using from now on in our, at least on Saturday we'll be using only the fetch. So that's pretty important, because I will show you how to use fetch for creating, reading, updating, and deleting the data. So all CRUD operations upon our REST API. API means API actually means application interface. I just wanted to see, let's see, API wiki. Yeah, application programming interface. I really hate, so the so acronyms in programming in programming or coding are awful. They're just totally awful, because I just use API as an shorthand, and then use like application programming interface. Or in REST, I use REST. I don't use RESTful API. Like REST means like restful. Like I don't know. There are some acronyms in there, and they're all awful. And there was a joke like in 2000s that Microsoft has really like highly paid person that gets that makes those acronyms, because they're totally stupid, and Microsoft like is responsible for half of them. So thanks Microsoft for stupid acronyms. But you don't need to know like what REST means or API means. It just means, so API is a way of getting some data, and REST APIs is just getting some data through HTTP. So that's about it. Yeah, that's about it for today. I just wanted to show you how to use fetch, and let's forget about how functions go to a queue, because they do in JavaScript engine, but let's just ignore that. So just ask me a question if you have. Just a quick detour. The problem with JavaScript and why it's hard to explain some concept in there, because there is a concept of threads in programming that can be run like sequentially or in parallel. And the problem with JavaScript is that JavaScript works on only one thread. Most of other programming languages work totally fine in multi-thread environment. And why is that important? It's important because all your processors on your motherboards, on your PCs or laptops have multiple cores, and you can run like one thread full time on that core, and so on and so on. And that's why, and that's the like. So you understand. So for me to explain why is it hard to explain in JavaScript something, I need to explain you a lot of computer science in there, and that's a big problem. There is not a really great way of talking about asynchronous functions, except here is a fetch. You can get some data from it. So that's why I wanted to create ask, just because you can use callbacks in this function here. So if we open here, you will see actually this ask are two different parts. You can see callback here. If you pass callback, it will actually just do something like this. The set timeout is just like artificial 1000 seconds, 1000 milliseconds injected before this continues to be run. And here is a way of how to do it in a promises. So promises and async await works with this part, and callbacks work with this part of code. It's not really important because this is a bit more higher level of writing code, and for some reason I made it to be almost unreadable. I need to like rewrite this to be better readable. And you can see answers up here. So guys, if there are no questions, I would just say wait until Saturday. So we will go through all the CRUD operations through REST API and using fetch to get the data, update the data, delete the data, and so on. We will also use modules. So if you haven't mastered the modules, we will do that a lot on Saturday. So I will put an poll on Slack, just so we know the future of the lectures, because I enjoy doing these lectures like an hour and a half long, but the problem is that there is not really that much more basic stuff worth talking about. I would need to go more in depth about some stuff, and that's interesting, but not interesting for everybody. Danica is working on another CSS lecture, so a bit more complex CSS lecture, so you will understand Flex and so on. But what I want actually to create are more examples. So I will let you decide like what's interesting to you and what we'll do in the future. Also, I said a Git lecture will be great, at least how to use Git and not how Git works, because that's a lot more computer science to talk about, and some like cool websites you can do or cool apps that you can make. If you have any idea about apps or some like what you want to do, you can ask me so we can create a lecture of building that app or that website, or at least a skeleton of that website or app. So this is pretty cool. Yeah. Beware of the poll that I will put in Slack, and that will be pretty cool to see what you think. Also, there is always option to go more on backend about node.js and how you can write servers with JavaScript. Yeah. So if there is no questions, I will just sign out, end the stream, and we can see each other on Saturday. If you want to play around with async wait, there is actually, I will just there is a great tutorial about promises that go a little bit deeper. I will link it in chat. It's a great tutorial on how to work on promises. I don't want to like go in depth in promises because it's more pretty advanced stuff, and there are no like you won't like need this kind of stuff while working on easy easy like front-end stuff like web apps or or websites. Those are mostly for backend, and on backend there are a lot of more promises than and async await than on frontend. So if you have any questions, ask me now or ask me in Slack. I'll stay a few minutes after the stream ends so we can chat a little bit more. But as there are no questions in chat, I'm signing out. So see you guys on Saturday, and prepare for their Pokemon project part 2.